So we're going to get into a little bit of the detail on how these go together. And there's a lot of different types of these, the roof terrace and the semi-intensive. We're really going to focus on the extensive roof. There's a lot of similarities, but as you increase in depth and you increase in sort of the complexity of roofs as you get into roof terraces, obviously the amount of detailing goes up significantly. Basically, there's a very small set of materials that need to go into it. There's a lot of products that people like to sell you. These are actually really simple systems. So you have a waterproof membrane, and the key part of roofing and implementation of a green roof is to protect the waterproofing at all costs. So you'll see like redundancy, and you'll see specific products, but also processes that are really aimed towards doing that. So protection layer that goes right on top of the membrane as work's done. There's a root barrier that a lot of times protection and root barrier doubles, either as a sheet that goes over that's also going to provide that root protection. A drainage layer. One of the things that causes maybe potential for failure is you want to capture as much water as possible, and you want it to saturate the entire soil profile. And then once you've gotten to that point, you want to get rid of it as quickly as possible. You don't want standing water, you don't want ponding. This is what creates potential roof failures, as well as creates potential conditions where plants are not going to thrive and the function of the roof is going to be degraded. So drainage layer, there's a bunch of different ways to do it, but it's a critical aspect of that. And then depending on the complexity of the roof and the elements, edging, curbs, maintenance pathways, ballasted areas, the process is really integrated. It has to be, because you're working with architectural elements, you're working with specific waterproofing requirements, manufacturer's requirements. So the architect, landscape architect, or architect design team is a really integrated process in that way, and really you can work through a lot of those details. And a lot of times what you're doing is not necessarily like working through the details to figure out the best solution. You can also look at it and say, well, if we raise the parapet a little bit, we could actually remove edging and run the soil and the plants right up to the edge of the roof, which adds more vegetation and less cost to the project. So some of the work through that is actually reducing cost and finding the optimized solution. And then that's sort of the substrate. Over top of that, growing media and vegetation. I focus specifically on irrigation systems, really essential for ag climate. And then there's a bunch of optional components as you get more complex projects. This is my one project where I've actually used trays, and we were required by the owner to use them because it was part of a GSA contract. There's certain conditions where you might use trays. If you had a lot of rooftop complexity, you wanted to have this sort of modular system. This is a bunch of plastic that's essentially, soil is going to be contained within the edging, so breaking it up into all these little units and incorporating a bunch of plastic into a project doesn't really make a lot of sense in that way. In certain cases, it may be something that you could incorporate into a design, but you'll see the sort of layering of all these systems here with the waterproofing, edging, irrigation, soil, in this case topography, and then the plantings. And that's going to be a very similar configuration. On more of a close-up level with extensive roof deck, drainage, protection layer. In this case, we had a low parapet, so providing a vegetation-free zone at the edge, and then the other thing of being able to edge and provide vegetation-free zones around drains to make sure that there's not clogging and things happening on that way. So you start to see the very few elements, and they're very sort of simply put together in the section. And this is pretty common to extensive and semi-intensive. And then obviously it's going to change a lot when you go up to extensive systems. There's a bunch of different things to choose from. Pre-vegetated trays, pre-vegetated mats, putting a soil down and actually being able to roll out pre-vegetated mats a lot of times is great instantaneous cover in that way. There's actually a system with bags. So the bags are pre-filled with growing media. You put them in, you cut some holes in it, and you put your plants in. So it's sort of this easy way, especially with maybe a smaller scale, or where a project where maybe access is an issue, where you can't actually get a crane and do large lifts of soil in that way. So you'll see a lot of systems, but thinking about it is like, what are you trying to accomplish, and does the system actually help you? And what happens is, a lot of times the systems will be tied to a roof manufacturer. So if you use a particular type of roofing membrane, they're going to say you have to use our system. The other way is it's really easy to just say specify system A, and then you don't have to do anything. It's all in there. I would say 99 times out of 100, custom designing a system and actually like looking at the best fit for the particular project is going to be cheaper and better in the long run. And there's a lot of projects that we've sort of pulled out of value engineering that were going to get cut because somebody specified a particular manufacturer and they're like, whoa, it's $50 a square foot. Like, we can't afford that, and actually go through the process, do some design, figure out what would work with a particular project, and you can cut that per square foot cost down to maybe $10 or $15. And that starts to become a lot more palatable for owners and takes it maybe off the chopping block in those cases. You'll hear growing media a lot instead of soil, making this very distinct difference and separation between the fact that this is not soil. This is a very highly engineered mixture of components that is built for lightweight performance to offer the best mix of organic matter, structure, and a media that will support plant growth. But a lot of times you'll get projects where, say your structural capacity is 12 pounds a square foot. You have to have a pretty dialed in soil mix to actually figure out like what's the depth, what's the configuration. And a lot of these times you'll see these numbers are actually saturated weights so that they're fully saturated. So that's like, for that soil capacity itself, that's the most that's ever going to weigh, as opposed to like a standard topsoil, as you can see, is significantly heavier than that. So what that's made up of is there's, again, a lot of different blends and a lot of different options for that. The most common you'll see in our climate is pumice. We have a lot of it, being near volcanic activity. Perlite as a lightweight mineral aggregate adds structure, but also keeps weights low. Other areas of country, you'll see expanded shale. That's another lightweight aggregate that is more regionally specific to certain zones. And then very little amount of organic matter, and it increases based on what you're actually trying to plant. But for the most part, a extensive, low-maintenance succulent eco-roof, you're going to see probably a maximum of 20% organic matter in the mix. The pieces that go into it are really important, but one of the things that is critical to growing media that you'll see, and some of the bigger failures that have happened over the years is, one is if you use a lot of organic matter, or you use things like cocoa coir, or things that are like fine particulate matter that like to break down, over time, the soil profile will start to compact. And that's, will degrade, plants won't be able to grow in it, and it'll not actually have the moisture retention capacity. Picking components that actually hold up long term and actually have a larger structure, like pumice, that's going to provide a framework. This happened on one project early on in Portland that I remember was they used a bunch of small grade materials. So it was organic matter, fine particle cocoa coir. It was all these like very fine particles, and they were like, oh, we want to make it lightweight. Let's put perlite into it. So they mixed it all together, put it on the roof. The first time it rained, all the perlite floated to the top and went right down the drain, because you have to create a matrix of all these things to like actually lock them into a structural media. So there's some great soils out there. I've been looking at some of the manufacturers locally are doing great stuff. There's also some really terrible ones that people are selling as green roof soils, and that's something that making sure that you're aware of sort of that long-term performance and something that has the function but also works for what you want to do. So I'm not going to pronounce this, but it's a great reference for all things green roof. A lot of the really modern green roofing, vegetated roofing technology comes from Germany. And so what they've done with this experience over decades, where we're maybe getting on our second decade of roofs. They've been doing it for 30, 40, 50 years. They've developed really great protocols, sort of similar to our ANSI standards and things where there's testing protocols. I think there might be more now, but I think there's one place now that will actually do FLL testing for green roof media, and it's Penn State University. You can actually send them a sample. And rather than a typical soil sample where it'll be like, here's your organic matter, here's your sort of relative relationship, they'll actually give you all these specific elements that are focused on green roof performance. So it's essentially testing media relative to green roofs, and so it's something where the guidelines are great. They're actually translated into English now, which is awesome, but it's a great resource for particularly growing media. We've actually been requiring it on projects now, so any submittal of green roof media has to fit within parameters that are considered optimal performance for vegetated roofs. So depth is obviously a product of both the structural capacity, the type of growing media, and then what you want to grow. So sometimes your limitation maybe on a retrofit is, here's our structural capacity, we have to work within that. Other times you're doing new construction, you're like, oh, we want to grow vegetables, so we have a little bit more flexibility in, say, increasing the depth and increasing the structure to match that. So a little bit of the rules of thumb, and these are not set in stone, but what you'll see for extensive, the most comfortable I feel with is about 12 pounds per square feet is the lightest you would want to do. You get lighter than that, you start getting soil media and depths that actually aren't doing anything for stormwater management. You get into like 2 inches of growing media. You also get really lightweight aggregates that start having the potential for blowing off the roof if they're too light in that way. We don't need 150 pounds per square foot to do an extensive green roof. If you're doing new construction, I'll usually recommend that the structure will build it to about 30 pounds a square foot, and that gives us a great 4-inch green roof that we can do a lot of flexibility with. Start getting into semi-intensive up to 40 to 80, so adding soil depth, adding potential biodiversity in that way. And then roof terraces themselves can get very heavy and very complex depending on the size and the type of vegetation that you want to add. Again, rooftop agriculture, the rule of thumb, it was always like you need really deep, really organic rich soils, so you got to have 100 or 150 pounds a square foot. There's actually some really great cases where developing really productive rooftop systems for like super lightweight, they work really good on retrofit structures, so things where you don't have to like have a ton of weight to be able to support that. Plants obviously are a key part of this, and it's one of those things where, again, the Germans, the Scandinavians that were sort of forefathers of this really had introduced the idea of succulent vegetation as the best combination of low maintenance and highest performance. And the cool thing is you start seeing why they're so good at this. It's like this, so this is on the Oregon coast. This is a bunch of actual Sedum organum, one of the Pacific Northwest native sedum species. This is what they naturally want to grow in. So they grow in thin soils. They grow on super hot, baked cliff faces. They're able to survive under conditions where other types of plants wouldn't be. So obviously it makes them a great candidate for using on vegetated roofs. So the key to this, so it's CAM plants, and this is crassulacean acidic metabolism. The difference between a succulent, like anything with like thick leaves versus something that's leafy. Leafy vegetation is great. It soaks in a bunch of water, it evaporates a bunch of water. It's like great for the water cycle and hydrology. What happens with that is if you put one of those plants out in the sun on a hot day with no water, it's going to go, whoa, it's going to evaporate all its water out, and then it's going to start to desiccate. So what CAM plants do, and this is predominantly sedums, is they wait during the day. They're just like hunkered down, and then once nighttime happens, they can actually open up their stomata, lose significantly less water through the evapotranspiration, and then they actually photosynthesize at night. So it's a great adaptation for being able to handle high heat, low water conditions. That's where sedums become like pretty big rock star. There's a lot of different planting sort of strategies that are in place. People are like, I want to use all natives, I don't want to use irrigation. There's a bunch of strategies that you can implement any of those in a particular project, but it's going to have limitations. Like for instance, sedums and succulents, there's a very small pool of actually native succulent vegetation in the Pacific Northwest. So if you want to use sedums, which are great, you have like 3, 4, if you stretch native, maybe 5 or 6 plants to choose from. Irrigation is another one where people are like, potentially, I want to do it without irrigating. This is a very much a discussion that's been happening for 15 years since we've started doing green roofs in the Northwest, is you can do non-irrigated green roofs. You're going to have significant amounts of dieback. If you have a project where you don't care about aesthetics, it's probably less of an issue. If aesthetics is part of it, then non-irrigated green roofs are going to probably be a little bit less than satisfying for your clients. So you have to have that frank discussion about, yeah, it'd be great if we didn't irrigate, but you want this to look good. The distinction being that you don't necessarily have to water it like a garden, that you're actually just providing enough supplemental irrigation to keep it alive through the drought period of our summer and maintain functionality and aesthetics. When we started doing green roofs, the first project I worked on, bringing in a bunch of 4-inch pots, so that was what was available. One of the challenges of that was finding people that would grow the quantities that we needed. So at the time, sedums were like sort of a specialty rock garden, a little more. So you would be like, hey, do you have this? And they're like, yeah, great, we have 12 of them. We're like, yeah, I need 12,000. So finding the quantities and like stretching to like grab, enough vegetation. What's evolved over time is the industry has actually really stepped it up with the popularity and the adoption of vegetated roofs. So supply, diversity, you have a lot of that. The other thing that's happened is we found every time you bring in these pots, they're coming in with their own soil that they were grown in. So you're introducing a very different soil than your very engineered media, for one. You're also introducing weed seeds and other potential issues. So we've had projects where we brought this in, it looks great, and then weeds start shooting out of every single pot, and then they start colonizing, and you start creating this really interesting maintenance dilemma of being able to keep up with. You're actually doing all this work to keep this thing clean and free, and then every plant you bring in is actually bringing in weeds in that way. My strategy of choice, particularly on extensive systems, is cutting. So people are growing the plants, and then rather than selling you a plant in soil, they're actually going to sell you pounds of bagged cuttings. The cool thing about sedums as well, they'll actually root out of any piece of the plant itself. So you distribute plants all over the soil media, and wherever there's ground contact in the right conditions, it'll shoot roots down there, and then it'll start to establish itself in that way. So it's low cost. You're not introducing any foreign material. You're not introducing any foreign soil. You're able to work with the diversity. So you can custom design mixes with like, here's the species I want, here's the mix. And one of the limitations is you don't get to sort of maybe do the patterning that you would want to with like other plants, but it's also the ability to really quickly put this on a site and establish vegetation. And then some of the other things I mentioned, there's the pre-vegetated mats and pre-vegetated that are sort of similar to those, where you can actually roll them out and quickly establish vegetation in that way.